In this video, we're going to be looking at adding and subtracting rational expressions. Now, back in school, you should have learned how to add and subtract fractions. So if you had something like this, since they have the same denominator, you can put them together into one fraction. And what would go in the numerator would be that, and you would get that. And that's all well and fine as long as they have the same denominator. But now if you had something like this, then the trick that you used back in the day was you had to multiply each of these fractions by the number 1, and the way you wrote 1 was important. And so these denominators 5 and 11 have nothing in common, so you would write 1 over here as 11 over 11, and you would write the number 1 over here as 5 over 5. So in red, we have the number 1. I'm just multiplying by 1, so that has changed nothing. And then you would multiply these, and so you just multiply the tops and multiply the bottoms. And now that they have the same denominator, you can put them together into one fraction, and we would get 33 minus 10 here. And so your answer would be 23 over 55. That is what everybody should have met in school, before university, before college. Now, if we're going to do the same thing with rational expressions, it is the same type of reasoning, except we're working with algebraic expressions and not numbers anymore. So if we have something that already has the same denominator, like this one does, well, we can just put them all together. You just have to be careful. I'm going to have 5x, and then I'm going to have minus x plus 1, and it's minus all of that. So if you just write minus x plus 1, that's wrong because you have not negated everything. So the way to remember that is when you have more than one term in the numerator and it's got a negative sign out the front, what you need to do is put parentheses around it so you won't make that mistake, which is what I've done here in the calculations. And then on the next line, put that distribute that negative sign through the parentheses, and then -1. And students are infamous for not making an extra line and saying, oh, I'll just remember to do that, carry the negative sign through, and they never do. And something like that is going to make you go straight to the wrong multiple choice selection. And so 5x minus x is 4x, and -1 plus 4 is 3. And so here's our answer. And of course that matches with what we had there, but we do have to have the restriction. You're not allowed to have 0 as the denominator of a fraction. If you do, it doesn't exist. Try and put anything divided by 0 into your calculator and you get an error message. So here we can see that x is not allowed to be 2, because if x is 2, it's going to make that denominator 0. So that's where we get, that should be a 2. That's a typo there. So I will fix that before you guys see it. So it'll make that denominator blow up. All right. And now, equally important is what to type when you get to web work. So if you just type, so what I'm doing here is wrong. If you just type 4x plus 3 and then have this slash x minus 2, you're telling WebWork that the answer is 4x plus the fraction 3 over x, then minus 2, which is not the answer. Whenever you have more than one character in the numerator denominator, you must put grouping symbols around them. Okay. All right, so I will get that corrected. It's x is not equal to 2. So when I was typing the parenthesis, I must not have shifted there. Okay. Okay, so on example 2, we have that now we have that they don't have the same denominator. So I'm going to have to do that trick. I'm going to have to multiply this by the number 1, which I'm going to write as 11 over 11 here, and I'm going to write 3x over 3x here, because I want them to have the same denominator. So this is going to become 2 times 11 divided by 3x times 11, which will be 33x, minus 7x times 3x is 21x squared, and 11 times 3x is 33x. Now they have the same denominator, so I can put them together into one fraction. And I can't do anything more with that. That's as refined as I can get it. And of course, and that's just going to be 3x in the denominator. And of course, x is not allowed to be 0, because if x is 0, that's going to make the denominator 0, and the whole thing's going to blow up. And again, if you're going to write that into WebWork, you have more than one term in the numerator, so you're going to have to put parentheses around it. And also x squared, you have to type that in. There is a list in Canvas on what to type. And so let me just quickly go to here. Let's go into Canvas. And right here, how to type mathematical expressions for your answers in WebWorks. You click on that, and it shows you what to type. Okay, so and down here we come to the fractions, but up here, you know, if you have something to a power. Okay, so always refer to that. All right, so let me go back to where we were. Okay, so let's come up to the next one. Again, we can see that we do not have the same denominator. So I'm going to have to do that trick again. And so to get these to have the same denominator, I'm going to multiply top and bottom of this one by x plus 1. And I'm going to multiply top and bottom of this one by x minus 7. Then the denominators for both of these are going to be x minus 7 times x plus 1. Okay, it's just the order here will be different. That doesn't matter. And now I can put them together. And what I'm going to get up here is 3 times all of that. So don't write that. That's wrong. It's times all of that. Okay, minus 2 times all of that. Okay, so that's what I've done here. Then on the next line, you can multiply it through, distribute it through. I'm going to have 3x plus 3. Then minus 2x. And then minus 2 times negative 7 will give me positive 14. And then I have 3x minus 2x is 1x, which I'll just write as x. And then 3 plus 14 is 17. And then there's nothing more to cancel. If that had been a x minus 7 or an x plus 1, I could have canceled it with one of those in the denominator, but it's not. Okay. And so that's going to be our simplified answer, but just understand you do have restrictions on that. You can't have x being equal to 7, because if it is, it'll make the denominator 0, and you can't have that. Similarly, you cannot have x be equal to negative 1. So I've just put that in there with the restrictions. But when you're typing in your answer, you don't have to type in the restrictions, but you will need to know restrictions later on. So if you're just typing what's in the black box in, this is what you put. You have multiple parentheses in the denominator, so you have to put an extra pair of grouping symbols, and they have to be square brackets. And again, I refer you to that web worksheet of examples. Make sure you put square brackets around the denominator. So if all you do is type in this, that answer is wrong because you have just told WebWork that you're going to have x plus 17 over x minus 7 all times x plus 1. That's what you've told WebWork the answer is. This is why you need that extra grouping around the complete denominator. So again, if you're not getting the correct answer, it could very well be that you had the correct answer on your paper written out on your calculations, but you didn't type it into WebWorks correctly. And that's when you need to click on that blue email instructor button. And for the life of me, when I'm recording grades and I see that a student has missed something, and I'll see that they tried to enter something in 30 times, and then I'll look at what they typed, and they typed something like that. And I know immediately that they got it right on their paper, but they didn't put it into WebWorks right. And if all they'd done was click on the email instructor button, I could have told them that, and they would have gotten the answer right. But I have a lot of students that just won't use that button. Okay. And also, if you have used the button, the email instructor button, you need to check your UTM email, not your private email, because that's where the answer will come to. And secondly, if you haven't heard back from me in 24 hours, then something's wrong. I always answer email instructor button requests, always. And so you need to write a separate email to me and say that you click the email instructor button, you haven't gotten anything back. I always answer those emails. Okay. All right, let's go on to the next example. Again, they don't have anything in common. So I'm going to do that same trick again. I'm going to multiply top and bottom of this one by 2x plus 1. And I'm going to multiply top and bottom of that one by x minus 7. And then they'll have the same denominator, and then I can put them together. So they'll both have denominator x minus 7 times 2x plus 1. Now up here, I'm going to have x plus 3 all times 2x plus 1. Make sure you put them both in parentheses or your answer is going to be wrong. Then minus, and again, 5x plus 2, all of that times x minus 7. Make sure you put them in parentheses or your answer will be wrong. Okay. And so this is going to give me 2x plus 1. So now I'm going to have to FOIL this. So x times 2x is 2x squared. X times 1 is x. 3 times 2x is 6x. 3 times 1 is 3. I might leave the minus sign outside and then put that in parentheses. 5x times x is 5x squared. 5x times negative 7 is minus 35. Plus 2x minus 14. Okay, now let me clean this up a bit. So I'm going to have 2x squared minus 5x squared. And that's going to give me negative 3x squared out the front. Okay. Then I'm going to have x plus 6x is 7x. And here I'm going to have negative 35 plus 2 is negative 33x. But then I have a minus sign out the front. So I'm going to have 7x plus negative 7x plus 33x. So minus 33x is negative 33x is 33x. So I'm going to have plus 40x. And yeah, I'm skipping steps, but if you look over here, it's done. And then what else did we have? I had plus 3 here. And then I had minus negative 14. So 3 plus 14 is going to be 17. Okay, and that's going to be my answer, which matches the answer down there. So again, this takes a more methodical approach. The only thing here is I did the foiling off camera, as it were. 2x squared plus x plus 6x, and x plus 6x is 7x. But all of you should be able to FOIL. Every single one of you should be able to get from here to here. Otherwise, we're in trouble because doing that is something that's a Math 100 question or a high school question, not a Math 110 question. Okay. And of course, here you have to distribute the negative sign through to every term. Okay. So that's what it would look like. And of course, we have our restrictions there. I think everyone can see that x is not allowed to be 7, because if it's 7, it's going to make the entire denominator 0. We should also be able to see that x is not allowed to be negative 1/2. Now, to get there, if you're not quite there, if you can't see it straight off, well, what's in parentheses, 2x plus 1, is not allowed to be 0 because it would make the entire denominator 0. So subtract 1 from both sides and then divide both sides by 2, and you get x is not allowed to be negative 1/2. So that's where that restriction comes. And yeah, if you were to plug in negative 1/2, 2 times negative 1/2 is negative 1, and negative 1 plus 1 is 0. Okay, and again, you're going to have to put grouping symbols around the entire numerator and the entire denominator. Since there's not any parentheses, you can get away with just putting parentheses around the numerator. But we have 2 sets of parentheses in the denominator. You have to put square brackets around there. That's what your web work input will be. Okay, and let's look at this one. Now, I very well could, I could multiply top and bottom of this one by x squared minus 4, and top and bottom of this one by x minus 2, and then they would have the same denominator. But that's going to give me a cubic in the denominator, and we just take a little bit of time. And remember, from Math 100, that's the same thing as x minus 2 times x plus 2. And it doesn't take much now to get these denominators to be the same, because all I have to do is multiply top and bottom of this one by x plus 2. So when I do that, that's going to give me x squared minus 4 in the denominator. So both of them will have x squared minus 4. So in the numerator, I'm going to have x times all of this. So don't write that. You have to put it in parentheses. So don't write x squared plus 2. That will be wrong. It's x times all of that. And so that's going to give me x squared plus 2x plus 5. This is certainly a correct answer. There's nothing wrong with this. Now remember, you cannot cancel the x squares. Can't do it. You can only cancel it if it's part of a product, and the x squares themselves are not part of a product. Okay. I prefer to write it like that because you can see what the restrictions are easily. When you just leave it like that, students can see that the restriction certainly is x is not allowed to be 2, but it's also not allowed to be negative 2, which is easier seen here. Okay, but you could have written it as x squared plus 1 if you're just putting the fraction in, and you would have only had to put parentheses around, but I've done it like that. Okay, so if you understand this video and the examples that we've done there, you shouldn't get anything in the web work assignments that will be a surprise. Okay, so I'm going to stop there and let you guys do your web work.